So let's do the nearest neighbor method on the same problem that we saw before. Okay, so we start from A because they told us the trip must start and end at A. So we're going to start at A, and from A, we look at our options. To go to D would be 4, to go to C would be 5, to go to B would be 10. So we're going to make the choice to go from A to D, which gives us 4. Then from there, from D, we have the choice to go to B or to C. B would be 2, or sorry, to go to C would be 2, to go to B would be 3. So we're going to take the one that's the smallest of the two. So from D, we go to C, and that gave us 2. From there, we have the choice. Well, we don't really have the choice because the only place we can go from there is from C to B, which is 6. And then from there, we go from B to A, which is 10. And that did not give us our optimal solution because that gave us 22. This is more of you're making the decision to not necessarily pick the most optimal route. You're making the decision at each point based on the information that you're given at that moment. So clearly in this example, that did not match the solution that we got from the brute force method. So what happened here is that when we got to this last part here to go from B to A, that's the biggest weight out of all of them. So let me highlight that in yellow. That right there is the largest weight, and by default, because from A to D was the smallest, and then from D to go to C was smallest. So then when we went to B, because we couldn't go back to A yet, that was less ideal. And then here, that by default left us with the highest weighted length to be included in our circuit. And so that's what we would call the relative error. That process left us with a high value remaining that we had to include. All right, so let's take a look at those. The brute force algorithm for solving the traveling salesman problem is an optimal but inefficient algorithm. It's inefficient because you have to go through all of the different possibilities, but it's optimal because it guarantees that you will get the optimal solution. The nearest neighbor algorithm for solving the traveling salesman problem is approximate, but it is efficient. Okay, so just keep that in mind. It's kind of like a give or take. You can either get the exact correct answer, but it will take a long time to do it, or you can take a shorter way, but you might not end up with a correct and exact answer. All right, let's do one more. It says there's pizza delivery store located at the position marked A on this graph. Okay, so that's A right there. Assume that deliveries must be made at the following locations: C, G, L, O, B, E, and M, and then the delivery driver must return to the store. So we're going to draw a weighted graph of the neighborhood. So I'm going to draw this weighted graph. It's not going to be very pretty, but essentially we have 7 vertices we need to focus on. We don't need to draw all the extras. Notice this hint here. Do we need to draw all of them or only the ones we're looking at? We only need to draw the ones we're looking at. So what I'm going to do is I'm going to draw 7 dots. And I'm going to label them. So we have A, C, G, L, O, B, E. Did I miss one? 1, 2, 3, 4, 5, 6, 7, 8. 8 total dots to represent all of the stops that the driver needs to make. Then I'm going to connect each vertex to all the other vertices. So I'm going to start from A. So I go from A to C to G to L to O to B to E Let me make this dot right here because that's apparently what I wanted to do. And then to M. And then I'm going to continue doing that for all of them. Then the weights, I would treat this as a block. Okay, so I would say how many blocks away each one is. So looking from A to C, I would say 1, 2, 3. So I would label this line right here from A to C as 3. From A to G, we have 1, 2, 3, 4. So this black line right here, and it's really hard to see because there's so many lines, would be a 4. And then A to L would be 1, 2, 3, 4, 5. So A to L, this line right here is weighted with a 5, and then so forth and so on. Is this graph guaranteed a Hamilton circuit? Yes. Remember that in order to guarantee it, it has to be complete, and it has to have 3 or more vertices, and both of those characteristics are satisfied by this graph. Now, consider the pizza delivery driver from this problem. How many Hamilton circuits does this graph have? Well, there are 8 vertices. So that means that there's 7 factorial, or 8 minus 1 factorial, possible Hamilton circuits. That's a lot of Hamilton circuits. Let's think about that. 7 factorial is equal to 5,040 Hamilton circuits. Which method would be the most efficient for this particular problem? Well, this would be a nearest neighbor problem because there is absolutely no way I'm going to write out 5,040 possible situations. Okay, so use your method of choice to devise a delivery route which will minimize the number of blocks traveled. I'm going to allow that I'm gonna allow you to do that on your own because going through this, this is already like 40 minutes of working through this problem, but the ones you'll see on your homework are much smaller. If you want to try and attempt this one, please do so. But there's also a video in the Pearson examples that specifically goes into how to solve traveling salesman problems with tons of examples. So also check out the Pearson additional media resources for 13.3. All right, y'all, thank you so much. Hopefully you understand the importance of this because if you are a logistics planner or a scheduler, you might really want to consider this. Or let's say you were trying to make decisions about moving. Let's say you wanted to move in the Metroplex. And let's say, I, for example, lived in Louisville, worked at Tarrant County College in Hearst, but then was trying to decide if I wanted to take classes at UTA or at TWU to take some additional math classes. So by making that decision, by thinking about how far away each one was, it helped me make my decision based on the cost as well. So not just the cost of tuition, but the cost of traveling to get there. And then my husband and I decided to move, and we had to decide where in the Metroplex we wanted to move to. So we had to take into consideration where he works, where I work, how far away we are from different locations that we wanted to be around, and we ended up in Euless. So anyway, this is kind of like the way you should think about any kind of logistics, distance planning, time planning, cost planning. As in, if you have questions, let me know, meet with me. I'd love to help. Thank you so much. Bye.